Hello, everybody. Welcome to Nakshatra's lecture series. We're extremely excited today to invite you all because we have a very, very special guest. And just to give you a bit of information about what Nakshatra does before we get this evening started. So we are a collaborative research platform, and we mostly focus on pure sciences, that is basically in physics and mathematics. So we offer courses in fields like astrophysics, cosmology, visual mathematics, aerospace, and so on. But we also focus on research groups. So we also have many project groups which are collaborative in nature. So whoever you are, if you're a student and you want to collaborate with some of people from around the world, work on something fun and exciting, then we offer those opportunities. And our main focus is connecting student communities with mentors. Today it's not so easy to get connected to mentors, and it's very hard to find someone who will lead you through your academic journey. And to be able to have that, for example, today we have a wonderful guest with us, and to be able to interact with such people is such an amazing privilege and honor. So let's get started. I would first of all welcome Dr. Ravi Margasahayam today. Thank you so much for accepting our invitation and being on the Nakshatra platform, sir. Just to give you a quick background about where he's from and what kind of work he did in NASA. He's actually from India, and he studied right here in Bangalore, where I'm from. And he received his bachelor's degree in mechanical engineering right here in RV College of Engineering. So he then moved to the United States, and he continued higher studies. He earned a Master of Science in Aerospace Engineering. And after that, he worked for 8 years in Boeing. So there he developed a lot of skills and in a lot of multidisciplinary fields as well. And he's been with NASA after that. Right now he's been with NASA for 30 years. So that's a lot of time to spend in such an amazing organization. So he's definitely going to have a lot of experiences to share with us today. And Dr. Ravi has worked on many programs, including Space Shuttle, Atlas, Delta, Titan, and of course, importantly, the International Space Station, ISS. So earlier, as a project systems engineer, he was responsible for transporting the space shuttle vehicle to the pad and getting it ready for launch. In his career, he has supported over 100 plus missions of the space shuttle. And he's also NASA's international expert and lead scientist on rocket launch-induced noise and vibration technology. And he will speak about it today and how it's a very, very challenging field. So those of you who have questions about vibroacoustics and so on, when it comes to the safety of the spacecraft, you can definitely ask him. He's the perfect person to ask those questions. And he has received numerous awards during 40 plus years of his professional engineering career. In 1996, he was awarded NASA's prestigious Silver Snoopy Award for exceptional engineering and safety innovation on the space shuttle. He has authored and presented over 50 plus peer-reviewed technical papers nationally and internationally. He organized and co-chaired the 9th International Congress on Sound and Vibration, called ICSV9 Congress in Orlando, Florida. Which was co-sponsored by NASA Kennedy Space Center. He also wrote a chapter in a book called Infinite Worlds, which is a book on the last Hubble Space Telescope mission. Those of you who want to take a look at it or buy it, you can do so online. And his photograph is displayed in a $100 million museum dedicated to Space Shuttle Atlantis at NASA's Kennedy Space Visitor Center. Lastly, he is a VIP escort and an international public speaker at NASA Kennedy Space Center. I mean, today from his talk, you'll be able to tell he's very passionate about sharing his experiences, sharing his knowledge, and making sure that the youth have enough information to achieve what he was able to achieve. So he has lectured in over 30 plus countries around the world. He has served as an official KSC escort and provided technical and historical tours to astronaut families, foreign ambassadors, government dignitaries, international visitors, and military officials. So his multilingual ability, which I'm sure he will talk about, coupled with the knowledge of world cultures and global promotion of NASA's mission and vision, earned him the title of KSC's Goodwill Space Ambassador. So today we have Dr. Ravi with us. I am so privileged and honored to invite you here today, sir. So let's get started with some of the questions. We have Karthik here today, Karthik Tiwari, who is a great friend of mine who will be co-hosting this event. So let's get started with some of the questions. So these were questions.
Can I just make a statement here, a quick statement?
Yes, sure.
Yeah, just want to thank Nakshatra and the team here for inviting me. Really, it's an honor and privilege for me to be participating today with all your team as well as all the audience there. I just lost my mother about 15 years ago and father about 15 days ago. So I want to dedicate this lecture for my parents who gave me the knowledge and the wisdom to carry out my duties as a good human being and being of value to the whole world citizens. And with prayer to Ganesha, we'll start the presentation today. Thank you.
Thank you, sir. It's definitely an honor to have you here. So these questions were put together. We kept in mind that there is a very diverse audience today. And of course, in Nakshatra, we have a community of over 150 people coming from all parts of India. So the first, we are going to I'll outline the format of the event for all of you. We are going to have two parts to it. So in the first segment, we are going to be asking him slightly more elaborate questions, and he'll tell us more about his stories and his experiences and his anecdotes. And in the second part of the event, we will focus on a lot of questions we received from the audience. So quick questions that he can answer. So those of you who are watching us live on YouTube, feel free to put your questions there, because we'll have a 10-minute to 15-minute window at the end of the event to make sure that all your questions are answered. So don't hold back. Just, whatever comes to your mind, what would you ask, if you were face to face with a NASA scientist, just put it down there. Okay, so let's come to the very first question for today. And of course, we would want to start by asking you, sir, what exactly was your background like, your childhood, and perhaps as a young engineer, what were your ambitions and your interests? And was NASA really on your career radar? And what were you aiming for as a younger professional?
I think it's a very good question. Every lecture I start with, I talk about, my background and my upbringing. As a kid growing up, I was in Burma, Afghanistan, and Middle East, where my father worked in many entities like the United Nations as well as the American Embassy in Kabul. And as I was growing up in Burma, we are talking about the multilingual. I knew more Burmese than my parents actually, but more importantly, many times he would take me to the field and I would see this Caterpillar, which is an American company, tractors running around because they were rebuilding Burma after the Second World War. So it was very interesting to see some of these structures, but really equipment and structures, but really didn't really click on me until I came to Mumbai after living in Kabul in the 60s, 1964. So after coming back to Mumbai, I saw a Bollywood movie called Sangam. And really that was the trigger. I don't know, many of you may not know Sangam, but it's a love story like Pearl Harbor between two boys and a girl, and really in the end, the pilot gets the girl. So really my thinking was that if I become a pilot like him, I could marry a beautiful girl and go around the world. But I don't think my parents really liked that idea because, first of all, my dad didn't make a lot of money. And my mom was like, okay, you fly, you die, So I think that's one philosophy I want to impress upon current parents is that, let your kid do whatever you want. But really, I didn't even know that I wanted to be an engineer until I saw Sputnik in 58. Really, we didn't know much about it. But more importantly, Apollo 13, I was already finishing my finished my high school and going to college, and really we had a spectacular failure, as you know, on Apollo 13. And at the same time, I also failed in my exams in Mumbai, and that's one of the reasons I came to Bangalore, to study engineering. And I want to impress upon people, saying that, okay, all these people are no, we're not as smart as you kids. You are also equally smart. So really, what I want to impress upon you is, failure is not necessarily bad. Sometimes even Dr. Abdul Kalam used to say that failures are good because it will detour you, take you back to your destiny, in a different path. Uh, that was very important. In the end, I never became a pilot. I never flew a plane. But I want to impress upon your audience, saying that, okay, if Plan A doesn't work, have Plan B. And as you know, India has many languages. You have Plan A, Plan B, Plan C, all the way to Z. And if you run out of letters, you just use different languages, basically. So like NASA even has like 6 contingency plans for shuttle landing. So my plan A didn't work to be a pilot, but like Leonardo da Vinci, who's my hero, I thought, okay, if I can't fly, I'll facilitate the flight of others. Now facilitate the flight for others. So I went to work on being an engineer from RV College. Went to America, became an aerospace engineer, and eventually wanted to get into uh, entities like Boeing or related entities where I could, really help the flight industry. And that's how I became an engineer and, learned about, flying. But not until I came to NASA, really, I knew about rockets. Until 76, when I went to Kennedy Space Center just as a tourist, I didn't even know what a rocket was, really, to tell you the truth. Uh, so in the end, what is the takeaway here? Takeaway is, you just follow your passion. There is a dream. You don't want to lose your dream. Dreams are very important in your life. They really make you grow into what you want to be. So that's what I want to impress upon you: is have a dream and follow your dream. And in my opinion, if you have a dream, the world will collude with you to make it happen. I think that's how I started working for Boeing for about 8 to 10 years. And don't get me wrong, as an aero engineer, I worked in railroads and mining and helicopters. So we'll talk a little bit about that later before I came to NASA. So I think trigger is important, dream is important, follow your dream is very important. Again, plan A, plan B is very important. And don't worry about failure. Failure was not an option on Apollo 13. But in your life, my life, failure is an option, And many people, including Dr. Kalam and many, Steve Jobs and Bill Gates and many, many famous people in this world, everybody failed, So it's important that, failure is an option, One last thing I want to impress upon you is that I met Tenzing Norgay in 1973 when I went to Darjeeling, and he always told me that, you don't walk around the bazaars of Darjeeling and end up on Mount Everest. You have to put in your effort, So just having a dream is not important. You have to think, believe in yourself, dream, and then dare, go after it, You have to act. Otherwise, you're not going anywhere.
Okay, so
I think that's all I have for the question, unless we can keep on talking, but I think we have that 5-minute limit. So
right. So so clearly you came from a pretty average Indian background, and you made it all the way there and did your master's. So when you actually first got into NASA, what were your first few months like, or first few years? And as someone from various different fields, how did you adapt yourself to being a part of such a huge organization and one of the leading organizations in the world? And how did you quickly learn the things you were supposed to learn?
very great question. Very great question. NASA is my passion. Yeah, as I said, I came to America as a tourist, actually, I guess Trump would throw me out now. And I didn't have visa. I didn't have admission. I didn't have GRE. I still survived, and kept on working towards. I didn't have a green card to get a job. Many, many things. So all those things had to happen. So my journey was not that easy. You have to go on your journey. Nobody else is going to go on take your journey. So it's important that you go through your journey, and that's what it led me working in Boeing in Philadelphia. We were working on Boeing helicopters. I was building the Chinooks and the tilt rotor. And one day, suddenly, we see the Challenger accident in 1986. 10 years earlier, as a young kid, IIT Chicago, I had toured the Kennedy Space Center complex as a tourist, and really, although I saw the Apollo Saturn V rocket and saw the big buildings, it didn't, really impress upon me because I was not attached to it, So only when Challenger blew up, I really thought that, Challenger, the crew compartment and the vehicle itself is built by Rocketdyne, which is part of Boeing actually. So really we were affected by that because Boeing name was attached to Rocketdyne and other things. So we were worried about not having another accident. And that's when really I started getting attached to NASA. And then I came to NASA in 89. It was also a fluke because, I was trying to, I had a good job in Boeing, Philadelphia. I didn't want to move anywhere. And then my wife, who is a medical doctor, she moves to Florida. And then I have to follow her. And the only place Boeing had an office was in NASA. But they said, we can't hire you because, you don't have rocket background. So anyway, this is a lot of difficulties and detours you get, but don't get detracted by that. So when I first came to NASA, I didn't know anything. Basically, I got a book. There are hundreds of thousands of acronyms in NASA and Kennedy Space Center. I had to learn all those. Just walking into the building, walking into the center the first day for the interview was amazing because I just felt that, way back in the 1963s when I was studying in high school in Mumbai, a girl came and said, John F. Kennedy has been shot. And that's the only time I knew about John F. Kennedy. And now I'm working in the namesake center. Our center is named after John F. Kennedy. So working there, it was amazing. And meeting people, NASA is an amazing place. It instills excellence in you, whether you like it or not. You become part of it. You become an eagle. Until then, I think I was flying with sparrows and crows. Now I started flying with eagles, really. Even today, my wife says, if I cut Ravi, in his hand, no blood comes out, only NASA comes out. And that's the passion we talk about, So how I learned, I think one of the things about education in India is a lot of studying from book, whereas in America, we were more exposed to really going to the field and touching and feeling and sleeping with the systems and stuff like that. And every day I would walk to the pad. And luckily, as a vibroacoustics engineer, I had to do a lot of instrumentation on the launch pad. And this really helped me to know every single system on the rocket. And I had a book I bought, and I knew everything about how the space shuttle works, how the astronauts get trained and everything about it. So all these things, nobody tells you to read. You just do your job and go home, 8 to 5 NASA sometimes. But I went beyond what my call of duty and tried to learn most things. And that's what happened in the end, is that I got a lot of benefit because I became a tour guide, went around the world, many, many things. But what is more important in NASA is the camaraderie and the team effort and stuff like that. So what I want to tell people is, yes, you want to aspire to be working for NASA. And I don't believe that, if people tell you, hey, you're not an American citizen, you're an Indian, here's the living proof that, I went to America as a tourist, as an Indian, and I made it in NASA. So if I can do it with the average intelligence and average grades, you guys can do much better. And in my the takeaway here is, I think the reason I think I became successful in NASA is because I pushed myself beyond boundaries. I created the possibilities. In the 21st century, not knowing all the answers is not important, but asking the right questions. So I used to ask the right questions, and I went through possibilities. In the days in India, teacher told me one question, one answer. Here in America, NASA, we look at one question, many possibilities. And more possibilities you have, more innovations you have. So unless you innovate yourself, you're not going anywhere. Nobody wants you. So this is what I will talk a little bit later about, what is the real crux about your students and your audience should do in terms of being successful. I'll tell you 4 things to remember. And one of those things was really to learn many things going beyond your job and learning those things. And as you told earlier, I got the Silver Snoopy Award, and I got introduced to Pamela Melroy and some of the astronauts. We'll talk about it later. And those people really mentor you and shape you and mold you. You're all of you are rough in the diamond in the rough. Now we have to just polish you, cut you, and show the brilliance, basically.
That was very insightful. It kind of related to that. You were just talking about astronauts. So
Yes.
clearly working as a ground systems engineer and on the launch pads, you must have interacted with hundreds of astronauts over the years. So what was your experience like being able to launch these astronauts, especially having interacted with Kalpana Chawla, some iconic people who've made history? And also from the mentorship point of view, what were a few qualities one can learn, irrespective of who you are? What are some of the qualities we can learn from astronauts? And what does it take to be able to have that kind of courage and go up there?
Great question again. And really it hits my heart, really. Earlier, we talked about 4 things I want your students to remember: think, believe in yourself, dream, and dare. Now, what I learned from the astronauts. So really, I was not supposed to be close to the astronauts. The only reason it happened is because I became a vibroacoustics engineer, which is sound and vibration. Rockets generate about 190 decibels of sound, highest sound generated by anybody in the world, 100 Gs, 3000 degrees temperature, many issues on the launch pad. A small foam like what hit Kalpana Chawla's rocket, Columbia, can damage the rocket. So I was involved with vibroacoustics, and because of that, I was involved with safety systems on the launch pad. And I was training the astronauts to do emergency egress. And that's where I met many astronauts, including Pamela Melroy and Kalpana Chawla, and solving problems, critical thinking, and things like that. And on one of the occasions, I solved a technical problem on the space shuttle, where we had a problem with a cooling system, water coolant loop, where it cools the crew compartment in space, and it got frozen in space. And that's how I got the award. But then I met Pamela Melroy, and she took me under her wing. Even just today, I got a small email from her, some anecdote she sent me with Kalpana Chawla. In fact, she really took me under the wing and said, look, you know so much about the launch pad. Why don't you pay it forward, be a tour guide and do things like that. So my association with, the astronauts started there, working with them very up close, but more importantly, the safety aspect and the engineering aspect. Many astronauts would come to the launch pad to see our safety systems, how the shuttle is integrated and stuff like that. So that's how I got to work with them up close. And they really tell you 3 things, which is what you wanted to know: self-esteem, have no fear, and risk it all. Self-esteem is one of the highest, most important factor for your success in life. You don't have self-esteem, you will never go anywhere, I can guarantee you. And I'm the proof. I lost 20 years of my life being a shy, introvert kid. If I'd met you, Sitara, 20 years ago, I would not even talk to you. I would run away from you. I was that shy kid. But that's what changed. I could not become a tour guide nor an international public speaker just being a shy and introvert kid. So I had to change myself. Second thing is fear. I was afraid of everything: fear of failure, fear of losing out, things like that. Fear has 2 meanings: forget everything and run up the hill, or face everything and rise. And that's what astronauts are: face everything up and rise. And that's what they taught us. Come hell or high water. You are going through hell, keep on going. That's what Winston Churchill said. And that's what the astronauts are. Like my astronaut friend, Andy Thomas from Australia, he was on Mir space station. There's a fire on the Mir. Nobody is going to come and help you up there. you're going around the world at Mach 25,000 kilometers per hour. There's nobody there. So you have to be brave. And last but not least, taking the risks. By taking risks, you may lose. But if you don't take risks, you'll be always a loser. You sit on your behind, don't go anywhere, don't take any risks. You'll never make a mistake, yes, but you'll never go anywhere in the world. So those are the three beautiful things really I learned from astronaut. But more importantly, I started flying with the eagles. Eagles are the highest amount of bird. It's the national bird in America. Eagles live for only 40 years, but then they go up on the mountain top and they really break their talons and other things. Wings, come up with new wings, and they live for 70 years. Why they want to change? Because they want to live and hunt for not only them, but their babies. And literally, they have a nest on top of the mile high, almost top of a mountain, and they push their babies from there. And today I'm here to push all of you. If you get a chance, go to Google and YouTube and get a video called Push on Eagles. And here a mommy eagle makes a decision to push that bird, which is a tiny bird which has never flown, and her own babies she's pushing. Okay. But until she pushes the baby, until the baby knows whether she can fly or not, it doesn't mean a damn thing that you have to be an eagle to know what it means to fly. And that's exactly what Pamela Milroy and Kalpana Chawla and all those people, Andy Thomas and hundreds of astronauts, many astronauts who are my center directors at Kennedy Space Center, they're astronauts. Cabana, Robert Cabana is the current director, but his boss, administrator at Washington, D.C. was an astronaut, many astronauts. So I used to know all these people because I was their VIP tour guide. And NASA is such an agency that we don't report to any department. We report directly to the President of the United States. So imagine me reporting to my center director, to administrator who reports to the President of the United States. I was just 3 levels below them. I didn't have a big degree or a grade or a title, but I used to report directly to the President of the United States through these people. And one time we had 600 NATO ministers. We had to take them through some of these astronauts. So that I just want to impress upon you one last thing with Casey. The only thing I want to say is we'll talk a little bit about whatever you want to talk about her. But one thing I want to say that she was the last person she spoke just before she went on STS 87, which is the mission in 1997. Me and the Indian ambassador, T.P. Srinivasan, were standing right in the building as she came out of the ONC building, operation and checkout building. And she was 2 feet away from us. We were in a cordoned area, and all these astronauts, it's like better than Indian weddings. We have like helicopters going around and all kinds of ceremony going around, and really sound and vibration going around. When they go to the launch pad, it's like amazing scene. It's like out of a Rambo movie or an Indian wedding, I would say. And it's very nice to see that. So she passes by me 2 feet away, and she says, "Thanks, Ravi, Dr. Ravi. Thanks for being here. We'll see you around." And next 8 minutes later, she became the astronaut from India, the first woman. So I got the credit to launch the first Indian woman in space. And a little bit later, 8 minutes later, we made sure Inder Kumar Gujral talked to her in space, which I arranged through NASA. And 1 billion people in India listened to that. So I think, that is my legacy. I'm not an astronaut, but I want to be remembered as an astronaut maker for many people.
Thank you, sir. So finally, we come to the kind of work you are involved with. So let's talk more about your actual field and what kind of work you did. We know that you were a safety engineer for a long time. So a lot of people had a question about, as an engineer and as someone being a crucial part of this entire mission, how do you make sure that it is 100% fail-proof? Like, how do you know that not a single thing will go wrong? And what kind of work and techniques go into making sure that it is completely safe, especially because it's carrying humans to space?
Yeah, I want to steal a quote from Dr. Kalam. So when Dr. Kalam came, he's my hero. um, by the by, we have a lot of people. Swadesh movie was shot at Kennedy Space Center, as you know, and we met Shah Rukh Khan and Ashutosh Gawarikar was the. But Kalam, Dr. Kalam said one thing when I mentioned to him that I was just an ordinary person working here on the launch pads. He said, no, no, no. I used to be the same person once upon a time in ISRO. And believe it or not, 50% of the mission success is because you move the rocket, you integrate the rocket in your office and move it to the launch pad and get it ready on the launch pad. The next 25% is lighting the rocket, igniting the rocket, and getting it to the space. And the remaining 25% goes to the astronauts, really, because they just fly on their own. There's nothing they do, really. They just sit there in the cockpit and go there, basically. So 75% of the mission success came from us. So I started, as I said, having the knowledge. Just want to impress a little bit upon you. I did some research in railroads, which led me to work for Boeing as a railroad engineer, then later on as a mining engineer and a vibrations in helicopters and other things, which really brought me to NASA. And I used my vibration knowledge there as a vibroacoustics engineer, measuring launch acoustics and vibration. And we were making sure that all the launch pad structures were had highest amount of reliability. That means there was no problem that it could fly off, like we had the case of STS-107 when in Colombia when Kalpana Chawla died. So, but remember, shuttle has almost 2.5, 3 million parts, just like Apollo Saturn V rocket, which had even more. And all these parts, the crew compartment, which had the orbiter, we call it the white structure, the two solid rocket boosters on the side, and the orange tank. You combine everything together. Everything has to be integrated, and these are fit to zero hairline tolerance, actually. And we make sure that we look at the design drawings, we walk the systems, we understand the systems, we touch and feel the systems, we have a lot of testing, and basically we make sure that this rocket moves to the pad very slowly. Can you imagine moving a rocket and this infrastructure, 9 million kilos? How do you move 9 million kilos on a road? What kind of roadbed should we have? How can we have a vertical rocket not vibrating, which will create a vibration problem? So all this tremendous amount of stuff we did, and moving to the pad and reacting to almost like 3 to 4 million kilos of thrust. If I put a thrust of 4 million kilos, you'll have a biggest crater in Bangalore. The whole ground will open up. And so basically, these are the things. By going to the launch pad, studying and understanding the drawings, understanding the systems, so you really hit upon the systems engineering aspect of my job. So I was a vibroacoustics engineer. Then, because I knew so much about it, I became a ground systems engineer, which meant that I integrated the orbiter when it came from space, and the orbiter lands on our shuttle landing facility, which I don't know, which many of you may not know. We have the longest runway in the world, and we have alligators on there. We have 300-400 alligators sleeping there. NASA Kennedy Center itself Space Center itself is a zoo. We have 500 animals and birds and mammals and stuff like that. So we have to worry about all that. So we bring those things, and we bring the solid rocket booster and move everything to the launch pad. So we are very particular about having the design done properly. But then the next thing comes is to make sure that the design is well orchestrated on the launch pad, meaning we are not deviating from the design and the operation and maintenance manuals. So that is what NASA was great about. We had the best ground systems team. In my 100 launches at NASA from 89 to 2011, I lost one rocket, but not for launching. It was because of landing. We lost Challenger for launching, but at launch, but Columbia we lost during landing. So in my time at Kennedy Space Center, we never lost a rocket. And safety, mission success depends on safety, and also it depends on engineering excellence. And we as engineers, we brought not only tremendous amount of engineering horsepower, but we had the best team, and all the work was done with teamwork. And there's tremendous amount of work involved. And, we have to have the courage and take the responsibility. We have to have the confidence in our decisions, what we make. We have to have the trust in the team, in ourselves, as well as trust in the team. We have to have the dedication towards the mission. We have to have family sacrifices. I used to sleep and eat and live on the pad sometimes. Continuous learning is another thing. But when the rocket takes off and has a beautiful, beautiful liftoff, from 0 to 8 minutes it will take to reach space orbit at Mach 25, which is almost 25,000 kilometers per hour in 8 minutes. It's amazing. It's amazing to watch. I wish I could take all of you to see a shuttle launch. Unfortunately, you'll never see that again, unless maybe in the videos. But that's what we did. And we were the best engineering team, ground systems team, the best astronaut makers in the world, I would say. I don't believe that there is one ground systems team anywhere in the world which can beat our team.
So
and I think there was one aspect about failure. There is no such thing as zero chance of failure. Nobody can design that. Failure is always there. So the shuttle was designed for 1 in 100 failures. As you know, we had 2 in 133 failures later on. So nobody can design, because you can't test the full-scale rocket. And so if that's the question, next question we'll talk about that. But I think I was a systems engineer, I was a vibroacoustics engineer, I was a safety engineer, and then I was a payload safety engineer sending 400 payloads to the ISS. So all these were under my, I have experience in all these. That's why we have so much knowledge.
So you also worked at Boeing, and just like, can you explain, like NASA has always been working in very close partnership with private players like Rocketdyne and Pratt and Whitney. And can you explain to our viewers in like better detail how this relationship between NASA and the private players has evolved over time during your career, and how what NASA's relationship was with Rocketdyne is different from what NASA's relationship is with SpaceX or Boeing for that matter now?
A very good question, because a lot of people don't understand NASA really in terms of everybody you talk to, they say they work for NASA. And I used to say that when I was a NASA contractor, when I just joined NASA in '89. But not until 2000, I became a real NASA engineer, quote unquote, working for the government of the United States, basically. So we have only about, out of 20,000 people at Kennedy Space Center, we had 2,000 NASA people direct, and rest 18,000 people were contractors. Just like me when I just came to NASA in '89. And then by 2000, I converted to real NASA engineer. So if you take millions of people working right now, at least 1 million people are working in NASA around the world, doing many, many different things. They're not all NASA people. I would say less than 20,000 people in the history of the world NASA had employed, and I was lucky. Just like Kalpana Chawla was not a NASA employee when she joined NASA Ames as a contractor, but then as an astronaut, she became a NASA employee. So there are only 20,000 people, and with 20,000 people, you can't build 3 million parts, or 5 million parts for the Apollo or the shuttle. So we didn't have the in-house expertise. And this is where the beauty comes. What NASA is the best is in dreaming. I want to use a quote by our friend Walt Disney. He said, everything, the empire of Disney started with just a small dream as he was traveling between London and Paris in a train. So this what we are dreamers. We want to do go to moon and Mars and beyond. We dream to do, like JFK said, not easy things, but they're difficult. That's why we want to do it. We want to do the impossible. We are looking for possibilities. And for that, what happens is basically we cannot do it alone. We have to use our minds and imagination and horsepower related to that to dream. And so that's where these people like Boeing and Pratt and Whitney or something like the SpaceX and everybody comes. Rocketdyne was one of the early pioneers in developing Saturn V F1 rocket engines, the 5 Saturn V engines, if you see. It was a liquid oxygen kerosene engine, whereas shuttle was a derivative where we had solids and liquid oxygen, liquid hydrogen engine. So basically, Rocketdyne was a precursor to our design. But then Rockwell International, they designed the command and service module. Grumman Aerospace designed the lunar module. General Motors designed the guidance computers, avionics, and other things. So many people we need to work, and we work with them as a contract basis. We tell them, okay, I want you to design the external tank for the shuttle, or we'll go to Morton Thiokol and say, we want you to design and build us and deliver us the solid rocket boosters for the space shuttle. And this is what we are doing right now. After the shuttle program ended, we were asking the Russians to take some of our astronauts to space. Now we are asking SpaceX, and we are giving them $60 million per astronaut. Russians, we are giving them $90 million an astronaut. So shuttle cost about $500 million per launch, which would divide by 7 would be about 70 million per astronaut. So really, that is what we do with a lot of our partner entities, and they give us an ability to explore beyond our solar system, like Voyager 1, Voyager 2. Voyager 1 was built by Advanced Physics Lab, which is similar to Johns Hopkins Advanced Physics Lab, similar to JPL. These are not part of JPL or APL, are not part of NASA. So NASA just has about 7 or 8 centers, but these are derivative companies. They work very closely with NASA, JPL and APL, but Boeing and Lockheed and SpaceX and everybody else, they're our contractor employees. And we ask them to do certain things, and that's how they do the work, because we just don't have the resources. But now we can plan on how to get to Mars. Isn't it amazing that we can take something like Curiosity rover and send it all the way to Mars, 30 to 100 million miles away, depending upon where Mars and Earth are, and land on a real small table, 4 feet by 1 meter by 1 meter table, and it's amazing that it lands safely. So these are the things we develop, and for that we cannot just focus only on design and building. We do design, yes. The shuttle was designed by NASA people, and Apollo Saturn V was again designed by Werner von Braun. But the actual manufacturing and making the components and integrating, is done by some other contractors. Like even today, Kennedy Space Center has many contractors.
Yeah, and getting back to the system safety problem, so NASA, as we all know and acknowledge, that NASA really works on the frontier of what we humans know about technologies. So, and obviously, it's very natural that there might be cases when people don't really, there might be unknown factors, like the O-ring problem in the Challenger. So, how does NASA reconcile with all these parameters, and how has NASA's design and safety philosophy evolved throughout this Apollo program and the shuttle era? Have there been any significant changes in how NASA approaches safety?
Yes, definitely. Coming from the safety background and working very near and dear to Columbia and all the shuttle programs, and also some of the other programs I worked on, safety was our utmost concern. And if you go back to the history of Apollo program, we try to use like Mercury, Gemini programs to help us with the designing of the Apollo program. So we use established technologies. We stress on hardware reliability. We used to, like Werner von Braun used to say, make sure every single component or a system should be tested and stuff like that, and then integrated together. We have the highest safety standard, like if I wanted to send a node 1 or Harmony node to the ISS, we used to test it at Space Station Processing Facility at Kennedy Space Center with a hairline tolerance, because if it doesn't fit on Earth, it's not going to fit on space. And there is no return policy of a module in space. I have to spend $500 million to send, say, one of the modules of the ISS, and if it doesn't fit like a Lego set, we're not going to have that module useful, so we have to throw it away. So it's impossible to do that. So it's very important that we simplified the operations. We tested as much as possible there is no really a way to test 190 decibels of sound anywhere on the earth. Nobody can produce that today. So how do I test that? So I have to test for structures. I have to test for thermal vacuum and other things, and the gravity, microgravity issues. So basically, we try to simulate as much as possible on the earth. But again, Von Braun was very particular to make sure that the whole solid, the Apollo Saturn V rocket, was hung on a crane, and we had to test the vibration testing on it. So otherwise, he wouldn't let us launch Apollo Saturn V rocket. One anecdote I want to tell you: the first time the Apollo Saturn V, not the Apollo 11, but Apollo Saturn V rocket was assembled, we almost didn't make it out of the vehicle assembly building. We almost came very close to the top of the building where the doors couldn't open anymore and we couldn't retract the crawler. So almost we never made out of the building. So we do goof up once in a while, okay? So many times we check the interfaces, we gain experience from previous programs and other things. But I want to tell you 4 things which we learned from Columbia and Challenger, and that applies to, I want to repeat this because it's important. So these are the 10 commandments I go by in my life. So first one was think, believe in yourself, dream and dare. The next one was have no fear, take all the risks and have highest amount of self-esteem. And the last 4 now, because you asked about safety, is that root cause analysis. So there are 2 aspects of root cause analysis. So Columbia and Challenger, although we know root cause analysis, people think it's a O-ring on Challenger and foam hitting on Columbia. It's not that. It's actually human error, because in both cases, what we did was we took a mean and a 3 sigma problem, and instead of a 6 sigma problem, we normalized it to 3 sigma and said everything is okay. That means the problem was very bad. We said, okay, problem is not that bad. And the managers went away with it. So basically human error. So root cause is always human error. In your own life, everything in the world is done by human, including whether you take an exam or do something in your house is done by humans. So root cause is human error. So NASA came up with another cause called the proximate cause. So proximate cause is always an engineering cause. So when you say Challenger, the proximate cause was the O-ring. And we shouldn't have launched it in the cold weather, but we did it because of the management rush to schedule, meeting the schedule. And that was a mistake. And then we had the same problem in Columbia. We knew about the foam hitting, but then it created, we created an environment saying that the foam hitting was not a problem. And one bad day, it hit us. So really, I just want to impress upon you that when we had the STS-125 flight, we lost a previous flight to that STS-124. We lost 3,000 bricks, which bricks, these are 10-pound bricks, much bigger than what hit Columbia. Columbia hit was done by less than a pound. So really, these bricks were flying off like at Mach 3, 3,000 miles per hour and a couple of thousand miles per hour. And I was worried about it. And I went against whole enough NASA to shut down the rocket launch pad, because the next launch was the STS-125, which is the last Hubble repair mission. And then my managers wanted to, throw me out and, get rid of me and stuff like that. I went into a quadruple bypass heart operations. I have an 8-inch scar to prove. So, in NASA, we have a rule that if you see something, say something. If you see something bad, say something. Otherwise, you'll be feeling sad your whole life, basically, that you knew about a problem but never, said something. And that's what we did. We knew, we were well trained to understand all the problems. And with that, we made sure that we followed this 6 or 7 logical things, like I told you, established technology, hardware, and other things. So going back to these 4 things: root cause analysis, understanding the systems, how systems are put together, multidisciplinary knowledge, and storytelling. These are the 4 fundamental things good for not only Challenger and Columbia, but for your own life. So every time you fail, find a root cause analysis, because it's your own mistake. You must know that. If you don't find root cause analysis, next time you'll make the same mistake. Understand systems engineering, how the systems are put together, and knowing how engineering of systems is done, you can understand how systems are done. That comes right from Von Braun. multidisciplinary knowledge. Remember, I told you earlier, in my own life and Leonardo da Vinci's life, who is my hero, I did work in railroads and mining and helicopters and commercial airplanes before coming to NASA. Leonardo da Vinci was doing all kinds of things. He was designing gears and helicopters way back in the 500 years ago. He was painting. He was doing military hardware, many things. He was cutting bodies right under the church's nose in the church basement. And this is what I mean by multidisciplinary. Just don't say, okay, I'm a mechanical engineer. I don't want to know anything about electrical engineering in this system. No, that's wrong. That's wrong attitude. And as you know, attitude determines your altitude. So basically, you have to understand that how to. You have to know many other knowledge bases. How else will you innovate? Innovation is really basically something somebody designed, but it didn't meet their criteria or your criteria. So you said, okay, this doesn't work, so I need to innovate, and you come up with a modification because there's a limitation. So there's a limitation. So you won't know the limitation unless you have the multidisciplinary knowledge. And last but not least, storytelling, like what I'm doing today, to tell my experiences, share my knowledge, share my experience, tell the world, saying that, okay, don't make the same mistake. So 4 things very important for anybody to remember. Again, I'll repeat: root cause analysis in everything you do, engineering of systems or systems engineering, get to know that. That means not just look at the trees, look at the forest. That's why you have to be an eagle. Multidisciplinary knowledge and storytelling, talking to the world and telling how it is.
Okay. So that was extremely informative. We do have a lot of questions coming from YouTube Live right now. And a lot of them, of course, are about how to get to NASA and kind of the journey from being an Indian and how we can possibly work there. But before we go into that, of course, those are more questions about education and training. One last question related to the missions that you were a part of, and importantly, the International Space Station. So it would be great if you can tell us a bit about your experience of working with such a huge, significant mission like ISS, and also the fact that different countries contribute differently to the ISS, right? So what are the implications of that? For example, it's perhaps easier for a Canadian to become an astronaut because Canada has provided a lot of funding to the ISS. So how does that monetary aspect come into determining the opportunities that people have around the world? And even though we look at space exploration as something that is driven by humanity, national and geographic borders end up playing a role at the end of the day. So I guess it's a 2-part question. So yeah.
Well, I think, yes. I think I have a favorite quote of mine. It says that, space is the ultimate destination for mankind to be, live and work, and basically, to orchestrate the creations of your heart and chisel the dreams within your mind, basically. I feel that, space exploration is in our DNA. We need to understand where we came from, unravel the mysteries of the universe. We don't know even where humans came from, Earth came from, and stuff like that, from the Big Bang Theory or whatever that may be. We also want to develop technologies on Earth. NASA has developed tremendous amount of technologies. I can send you a big list of technologies. 2 simple things: cellular technology and satellite technology. Then now it's Internet of Things, which will be done by Elon Musk putting hundreds of Starlink satellites. So without that, really, we didn't have this communication. See, look at the history of mankind coming from Africa. We did 2 things best. We talked, we communicated basically, and then we transported ourselves from Africa. So communication is a vital link for human survival. And you don't want to be going back, hundreds of years using smoke signals or drums or whatever, or sending birds, So I was instrumental in sending the payload called Opals. But Opals was the laser beam which beams from space onto a station in California, and then it picks up the signal and we can download large amount of data. But let me go back a little bit. As I joined NASA in 1989, right around the time we were getting ready to launch, well, in about 7-8 years after that, Bob Cabana, who's our center director, his famous quote is, "From small beginnings come great things." He was the person who put Node 1 in space on STS-88 in 1998. And Zarya module from Russia on a Proton rocket went around December of 1998 at the same time, almost around the same time, I think November of 1988. So when they merged together in space, that was the start of the International Space Station. So really, it's a most fascinating single object ever built by mankind at $250 billion. It's the most expensive object built. I don't even know what the cost of pyramids and stuff like that, but don't forget, pyramids were built on the ground. Yes, 5,000 years ago, yes, but now we built something, a 5-bedroom house. Remember, like imagine a 500,000 kilo house up in space with almost 30 to 50 launches, one at a time, sending modules like a Lego set and putting them in space together. As this Zarya or Node 1 were moving around the world every 90 minutes at Mach 25 at 25,000 kilometers. So how do you first of all even rendezvous with this object, and then you have to make sure that you grab it with your robot arm on the shuttle, and then you take your payload compartment, open it, and put this module in space, and so and attach it, and they have to work. Otherwise, as I told earlier, there's no return policy in space. You buy a faucet for your house, you can go and return it in the hardware store. In space, you can't return it. So, and I think it was a beautiful orchestration by almost like a heavenly dance. It reminds me how NASA and all these international partners, 16 countries, now it's gone up to about 80 countries working together in space, all put these modules together one at a time. Many stories we can talk about, but my work directly was involved with launching the rockets. To about almost 33 times we launched the space shuttle, and every single time I had to make sure that take the payload compartment, open the payload bay, and put this particular module, whether it could be multi-purpose module from Europe, or a Zarya, not Zarya, but Node 1 or Harmony node or something like that. All these modules were put in the payload compartment, move the shuttle to the pad, launch the rocket, and then send it to space. And that was our role in almost from 1998 to almost 10, 15 years until the completion of the International Space Station. And so we are almost living 20 years in space, living and working. And I just cannot imagine myself, as a small boy growing up in India, thinking that, mankind will ever live and work in space. I mean, all we saw was moon and sun, and we didn't even know much about astronomy those days. I guess very little, things like that. So I think working with the international partners, each country is providing a different kind of module. And that is amazing for me, because that helps us to like Japan is giving us a Kubo module. The Russians are giving us the Zvezda and the Zarya module. We need to, make sure the International Space Station stays in orbit. And, if it comes out of deorbit a little bit, we have to boost the orbit to make sure it stays in the right orbit. Otherwise, it will fall down to Earth. We also have American modules, and then we have the ESA Columbus module. I think it's important to bring the international people because, I think it's a challenge that NASA faced, that one country, one person cannot take on this challenge. And by collective intelligence and collaborative activity, we can do more, And in fact, I've been working with ISRO since 1998. First, I came to see Dr. Kasturirangan. We've been trying to bring NASA and ISRO together. And every time something went wrong, and either it was an atomic bomb or it was some other problem, or one time it was a Challenger problem when two astronauts were supposed to go on the shuttle, got delayed and never went. So things like that. So I feel strongly that mankind has to work together in space. And now NASA is working up with a global strategy to bring all the partner countries in the world to go to Moon, Mars, and beyond. And I think the humankind, mankind has to do it because we are dwindling our resources on Earth, and we have to do asteroid mining and other things. Like some of these asteroids have 30 trillion, $100 trillion worth of things, like gold and diamond and platinum and many minerals and things, materials which are very rare materials, which really are very important. But I think my most important payload, I would say, to launch, well, two most important payloads, three, let's say three. One was 40 Japanese mice I sent to space, and they we didn't our thermostat didn't work one day, and we lost about $500,000 worth of cheese, which was supposed to go to the ISS. So I had to call Japan to get the cheese. These mice needed the same kind of cheese up in space, so I had to. They were airlifted for $500,000. So that was my real fun part. But the most important part is looking at dark matter. So I put alpha magnetic spectrometer, which is a $5 billion machine, which is put on the exterior of the ISS. But I think the most important payload in the world I launched to space would be the astronauts. Well, like Pamela Melroy, who put Z1 Trust and all these people. I think the human payload is what makes it the most beautiful thing for me.
Okay, so I think there are some really interesting experiences that you've had. So we finally come to the much awaited question. I think we got 40, 50 different people asking this exact same thing. And so yeah,
must be very important. Not my date of birth or my checking account, right?
Yeah, very important to each of them who asked it, I'm sure, personally. So including me, I guess, and a couple of us sitting here right here on the call. So the question, of course, is being from India and being an Indian origin person, what exactly is the process to, there are, I guess, two parts to the question. And the first one is getting into NASA itself. And of course, the times have changed. The political scenario has changed. The specializations required has changed. So if you can comment about, first, just primarily how to become an employee of NASA as someone who's Indian origin. And I guess the challenges of really working in another country's government organization. So, and why it is so hard to perhaps be a part of that. A lot of them had questions about how we could, probably do internships under NASA, and why that is extremely hard. And I think if you can outline just the logistics of it and why it's not so common that Indian students are able to intern there, that would be great. But also if you can offer some, steps to becoming an employee. And then we'll come back to the second part of the question later, which is, the astronaut and how to become an astronaut.
Okay, well, let's take one step at a time here, right?
Yeah.
So, okay. Well, let's, first of all, I think I mentioned earlier that, the moment you say it's impossible, then everything goes haywire, basically. Impossible should be saying, I'm possible. Remember, we talked about possibilities. And if you look at every single, company in America and the world now, they talk about possibilities, which NASA was doing it much before. But, NASA is such a great entity to work for. I just don't have to go anywhere and stand on a podium and say I'm from NASA. I just wear my T-shirt and people know that you're from NASA. And really, I don't want to boast here because I was never supposed to be at NASA. How could two ordinary people from India, me and Kalpana Chawla, on different voyages, different paths, different journeys, end up at Kennedy Space Center, and I get to launch her out of 1.5 or 1.3 billion people in India. It's impossible, right? So the fact that, we did think that, we never thought that it was possible or not possible. We just took the journey. I think that is very important for me. The journey itself is very, very important. You take the journey, you never know, you don't know the destination, but you must journey, and only you can journey. And we took the risk. We risked to go to America. And as I said, I went on a tourist visa. I should have come back within 6 weeks, but I think luck favored prepared mind, and I had the passion to study aerospace, and that helped me. So basically, I would recommend higher education. Like I came to America to get my master's degree, and I want to impress upon you one more thing. When I got my citizenship, the judge who made me a citizen of America, he said that don't let anybody tell you that you are white, black, or brown, or you are not American citizen. Yes, you are naturalized citizen. You are not born citizen, but you just happen to come a little bit late. Because America was always a land of opportunities, and America was land of old Indians, red Indians, things like that. So the foreigners came and occupied those lands, and they made they occupied and they became American citizens later on. So it doesn't matter whether you come like in 1975 or you come, in 1776. In your case, some of these students may be coming 10 years later or 5 years later. So really, my recommendation to them is to get a bachelor's degree in India, and start having this passion towards space even early ages. Study what you want, and study, go after the areas of expertise. If it's not possible in India, then find a place in the university system in America to get a master's and a PhD. And America is such a land of opportunities that I can guarantee you right now that if space is the next frontier which mankind has to explore, we just don't have enough engineers who are passionate about space, or who are knowledgeable about space. Just like the IT environment, IT revolution came around 2000, when hordes of Indian engineers came from India to take over entire United States, basically. And every single corporation has an Indian CEO now, right? So basically, all I want to tell them is, that don't start with the premise that I can do it. And, that's where you shoot yourself in the foot. Take that journey, and say that I want to be a best engineer in whatever I want to do. Forget that you want to end up in NASA. Then once you come to America, you study in engineering and get a job in wherever you want, like Boeing or related entities, and slowly make your way to NASA. It doesn't mean that, you must work for NASA. Actually, there are a lot of intelligent people working for JPL, which is not part of NASA really, which is part of California Institute of Technology. And they are doing great jobs. I mean, take a look at Perseverance rover and Ingenuity helicopter, okay? I never thought that, in my lifetime, when I built Boeing V-22 tiltrotor and Comanche and Chinook helicopters, I never thought that, we would be flying a helicopter on Mars or any other entity in the solar system, and we are doing it. So it doesn't have to be NASA, to be the best in the world. I don't think you have to work for NASA, but if your passion is that, go after it, and we'll help you. NASA will need more and more people. Whether you work directly for NASA or you work inside Kennedy Space Center has no bearing, because when I used to work for Boeing inside Kennedy Space Center, we told the world that we work for NASA. And many people in NASA itself have never stepped on the launch pad, and they still call themselves they work for NASA. They may be just doing some mundane work in the office. They still call themselves, because we are a team. We don't put them down because they are not working on the launch pad.
Yeah, I think that covers kind of how we can kind of pave the way to opportunities there. It might not be a straight road, right? But we can definitely pave the way.
Well,
And this brings
journey of 1,000 miles starts with a single step, right?
yes.
So basically, you have to dare, and you don't look failure as the end of the journey, but the start of the beginning of a new journey. You know, and the
Yeah.
only impossible journey is the one you never started.
Yeah, so I think those students who had the question, as he said, just make the initial moves and I guess be courageous enough. And this brings us to the slightly more tougher question of those who really have that childhood ambition and have retained that ambition of becoming an astronaut and going to space. And we know that there are very few people who've actually been to space. So, what does it take to, I guess, become one of them? And as an Indian origin student, maybe you can share a bit about Kalpana Chawla's journey, or I guess tips that are more relevant to today, because clearly the times have changed.
Uh, very, very interesting question for the students, really. I get many, many emails and many LinkedIn questions about how do I become an astronaut, and many girls and boys in India now, everybody wants to be an astronaut, you know. And really, I really appreciate that thought itself, that, you know, they have a purpose in their life, you know. When I was growing up, I didn't even know where I was going. I didn't know what was my goal and purpose in life, you know. At least you kids, whoever is aspiring to be an astronaut, have a purpose and have a goal. And all I can say is, you know, don't move the goalpost. You know, if you don't reach the goal, find alternative ways. You know, different. Take a detour. You know, and put a new map on your GPS or whatever, get you there. You know, plan A, plan B, plan C, all the way to plan Z. And if you run out of alphabets, you know, go to different languages. You know, so my thinking would be is to start working and to see whether now India wants to go to space, and ISRO wants to send manned space flights. So ISRO would be a logical choice, being in Indian. But now, if you are really bent upon coming to America or going to ESA, you can go to Japan and become an astronaut from Japan. It will be a little bit tough. ESA is also a little bit tough, but nothing is impossible, you know. So America is easy because, I mean, is also tough in the current environment, but this current environment will go away. And because we have what they call as ITAR regulations, where there is international trafficking in arms and other things, NASA is worried about safety and other things. And that's one of the reasons they're not giving internships to people and all that. But as you study in America and become part of a entity like Boeing or Lockheed or whatever, it is possible. So now, how did Kalpana Chawla become an astronaut? She never desired. I don't believe that when she left Karnal, she said, "Okay, I'm going to become an astronaut." Yes, I remember people telling me, and I'm reading. I read about her. She was putting the space shuttle on her, posters on her living room and other things, study room. But I think once she came to Texas, she started flying because she met her future husband there, and who was a pilot. And that's when she really started thinking about, looking at NASA. And Houston was very close by. She was going to study at Arlington. But the next best thing she did was to go through the path of least resistance, that she went to study at the University of Colorado, where a lot of our astronaut candidates, we call them ASCANs, these people are selected out of many, 12,000. I just got an email from Anima Sable. She's one of the Indian ladies. She's working for Houston, JSC, Johnson Space Center, and she wants to become the astronaut. Raj Chari, one of the Indians, his father is Indian, mother is American, but he was born in America. He's a fighter pilot. He became a recent astronaut. Well, then you had Sunita Williams. But in Kalpana's case, she didn't have all that opportunities. So she had to meet all these future astronauts who were astronaut candidates and work with them to see how she could. So she learned how to fly, how to scuba dive. So all the requirements NASA had to put you even the application process in, to make sure she tick marked all the boxes, and she made herself aware of all the things. And that's really helped her to be suitable and a candidate for astronaut. But then she did one more thing. She didn't have the actual work experience, so she went to NASA Ames, working on CFD models and and stuff like that. And that's where she met very many NASA people. NASA Ames is one of the oldest centers for computational fluid dynamics and looking at aerodynamics of flight structures and stuff like that. Even the tilt rotor V-22, they designed and testing it there. So as I went to America in 75, Kalpana came in 82. By 88, she had already joined NASA Ames. At the same time, I was at Kennedy Space Center. We didn't know each other. And she was not part of the astronaut program. And then by the time she had her PhD and she in University of Colorado. And next thing I know, I got my Silver Snoopy Award in 96. By the time I was already working with astronauts on the launch pad. And Pamela Melroy, who is my mentor and who is the person really who kicked my behind to be where I am today in terms of, well, actually 4 women kicked my behind, I guess. My mother, my aunt in Chicago, my wife for 39 years now, and obviously Pamela Melroy. These 2 women changed my life. So I just want to let you know that. So somebody has to push you. And I think some of these astronauts pushed Kalpana that you can also do it. And she kept on applying. So a couple of times she failed to get in. And then finally she got in, I think right around 96 when I got my Silver Snoopy. And that's when I found out about her because she came to visit us. So there is a logical process. The question is, are you going to take that risk? Are you going to say that goal is too far away? That is the important question. Now we have to tell me. So, I mean, that's my part of the question. If you give up, you'll always give up in your life. If you risk it all, you will make it happen. Basically, you have to innovate yourself. You have to venture the unknown. Basically, here. And I'm not saying it's easy. It was not easy for me also. I didn't have I didn't even have admission. I didn't even have a, tourist. I came on a tourist visa. I didn't have money. I didn't have, clothes, winter clothes. I didn't have books, and then I had to get a green card to get a job. Or without a green card, you can't get a job. Or without a job, you can't get a green card. So I had to go through the hurdle. And at Boeing, they won't let me inside the library because I had a red line on my badge which said I'm a foreigner, and I had to fight that problem. And then coming to NASA, coming to Boeing itself, I was a railroader and a miner. They won't let me, fly helicopters or work on helicopters. And NASA, they said, you don't even know anything about rockets. Have you even know a rocket? Have you seen a rocket fly? I'd never seen a rocket fly, by the by. So that tells you that, you go, I think I call my journey as a serendipitous journey. I started from India without knowing where I'm going to go, but I took the leap of faith, believe in yourself, that's the most important thing. And I'm telling you from looking back, 20, 30 years, like there's a Chinese proverb, you want a tree in front of your house, plant a seed 20 years ago. If not, then plant it now. If you don't plant it now, you're not going to get a tree 20 years later. So don't make that mistake. I lost 20 years of my life. I don't want all of you to lose that. Don't be shy, introvert, loser, giving up, afraid of fear and failure and stuff like that. You do that, you're not going anywhere.
I think that gave all of us a lot of clarity and a lot of stuff to think about as well. I guess the road to becoming an astronaut has not always been clear, and a simple Google search won't really give you the solution, unlike some other things that you can Google easily. So your insight is definitely very, very valuable. So we are going to be moving into the next section of the event where we'll be asking him, some really quick questions. So before we do that, we'll just give Dr. Ravi a 1-minute break so that he can just rest a bit. So I guess we'll start exactly in another minute. So before that, I can just let you all know a bit more about what we do and this particular platform. like I said before, we're going to be having a lecture series here on YouTube Live itself. And our main objective, like I said, is to bridge that gap between students and mentors, and also between where students need to be in terms of research skills or academic skills. And that training is not something they get in their undergraduate level, or at least a majority of students. So we are really trying to kind of redefine how that is given, how that knowledge is delivered to students. So we will be launching something exciting in the month of September for all of the students out there who want to take up some certification courses, but you don't want to do a normal MOOC. We have some exciting announcements for that. Right now, we have around 7 different teams and crash courses already going on in astrophysics, Python programming, and computation, and so on. So if you're somebody who knows that you have to perhaps work on a couple of skills and brush through them, learn them, work on your weaknesses, and then also probably work on a collaborative project to improve those skills, then Nakshatra is the right place. We connect you with people who are just like you, like-minded students who want to work on something exciting together. So that's definitely there. Another thing is we see so much talent here. The kind of applications we got is amazing. So we also invite you all to be part of the decision-making process in Nakshatra, because we are not just a individual isolated body. We want it to be a community always. So we always want to take suggestions from you all. If you have ideas for what truly matters to you, which you're not perhaps getting in your college or your traditional education, then we definitely request you to write to us, join our discussion forum. Telegram is a great place for you to keep in touch with our community. The link is given in the description below, so you can join our community. There we have more exclusive events that you can get access to. So I would also suggest, if you've not subscribed, please subscribe, because we'll be inviting more such interesting people over the next 2 months, especially August and September. So please make sure you don't miss any of those events. Okay, so now we'll move on, like I said, to section B of the event. So, sir, you can take perhaps a minute and a half to answer these questions. These are coming from our audiences as well as people who've written to us. So, Karthik, let's get started.
Yeah, one of the very common questions was like, people wanted to know your general estimate. When do you think NASA, or in fact any country, would land people on Mars in the coming 20 years, 50 years, or 100 years?
I'll take an engineer's guess. I would say within 20 years, or sooner.
Okay. All right. Next question. This is actually doesn't seem like a short question, but anyway. What are some of the ways in which the ethics of space exploration and space colonization presents complexities in the workings of NASA?
Can you repeat that again?
Yeah, this is basically about space ethics. So this was a specific question from a girl who
in
wrote
what
to
regard?
us.
What regard?
Right. So if you colonize a different planet, that planet could already be, it could already have some amount of life in it. And how does it make sense to go and occupy other such worlds? And isn't it more natural that you stick to the planet that you were born in? And is it fair to do so? Is the question.
So that's a good question, actually. How do we know that we are, born? Well, some of us were born here, but how do we know that we don't have other, parts of our ancestry somewhere in other planets, right? As the solar system formed. So until we put the Hubble, we didn't even know how old was our universe, right? And how old was Earth? Like 4.5 billion years old, and the universe about 13.5. So all that, there's a nice quote from our director, JPL director. He says, the scientists study the world as is, but the engineers create the world never was. So, I don't want to call myself as a rocket scientist. I want to call myself as a rocket engineer, because I want to create a world which never was. And, I don't think that we're not colonizing, we are exploring. There's a difference between colonizing and exploring. Just because you go from Bangalore to Chennai, doesn't mean that you're colonizing, you're exploring, you're trying to see the countries. As a kid, I was exploring, like my whole world was Burma and Afghanistan, I didn't even know anything beyond that. Only through National Geographic, I knew the world, And I started exploring. Now I've gone to almost 70, 80 countries. So really what it means is that, you have curiosity. Humankinds have curiosity. That's built in our DNA. And we want to see what is on the other side of the hill, Okay, give me a break now. Like we are flying a Ingenuity rover, a helicopter on Perseverance rover. And so what is the purpose of that? So Perseverance rover has a difficulty going above the hill and doesn't know what is on the other side of the hill. Okay, so what do? We send our helicopter and say, hey, Ingenuity, go around the corner, fly and find out what is there, right? How beautiful that is. Okay, now maybe why do you want to think in terms of colonizing? Maybe they may need our help in some ways, Maybe they want us to terraform whole of Mars. So it could be better living for them. So basically, yes, I'm against wars. Like, we had the nuclear atomic bomb put on Hiroshima, Nagasaki in world wars. And I'm against wars, but I'm not against exploration, especially when you have 7.5 billion people on the earth. We are going to dwindle our resources. Water may be a problem someday. Food may be a problem. So why do you think ISS is there? Who is watching Mother Earth? ISS. When you go to the beach, there's a lifeguard on the beach to watch you so that you don't drown or a fish is not going to eat you like a shark. But who's watching Mother Earth? ISS. ISS is our Earth observation station. It's watching us. So that's what we are doing for Mother Earth. But also, don't forget, I don't know whether your students are aware that my first year in NASA in 1990, I sent Magellan to Jupiter. I sent Galileo, Magellan to Venus and Galileo to Jupiter, Ulysses to Sun. So we are looking at solar flares and how they are going to affect all your satellites. So you can put all the satellites in the world, but if they get burned by solar flares, we'll be in deep trouble, So really, we are looking for the universe. What is the purpose of putting Voyager 1? Voyager 1 was supposed to just go to Mars, but now it's going beyond the interstellar space. Why? We want to find out where we came from. Maybe our ancestors are there. I don't know. We want to find out and help them, So think in a positive note, but let's say that we never reach Mars and we never colonize anything. But just the exploration of space has completely changed. And look at, I was born in the 50s, and last 50, 60 years, how the world has changed, just compared to last 2,000 years or 5,000 years, So that is my answer to colonization. So I think you have to reframe the question, you say, I'm exploring for better,
Yes.
A lot of people also wanted to ask you about the progress of the Artemis mission. Do you think, when do you think they're going to launch? When do you think we're going to go back to moon again?
Yeah, well, there is the Lunar Gateway and Artemis, and right now there is some delays because they wanted to concentrate more on ISS and making sure that all the funding and support goes to ISS. There's tremendous amount of benefit and kind of research going on ISS, in terms of astronomy, astrobiology, physical sciences, material science, space weather, space medicine, many, many things. So really, NASA has only so much money, $20 billion actually, so we have to apportion the money to the right place where we get maximum benefit for maximum bang for the buck, as they call it. So you put $1 and you get $10 benefit. That's where the money goes,
Okay, so very, very quick question. If you're someone who wears specs, can you become an astronaut?
Yes, you can.
Okay.
And just to go back to the ISS, how long do you think ISS is going to be functional in the coming years? Because it has been tremendously successful for the past 2 decades. How long do you think ISS lifespan is going to last now?
We were planning originally for 2024, but then I guess there was request by the Japanese and Europeans to continue the service, and so Right now, our plan is to continue at least until 2028, maybe even 2030. We need Russian partner for that, and as long as we have good relationship with Russia, we should be okay, because one key factor is that we need a Zvezda module, so that if the ISS comes out of orbit, it will burn in the atmosphere. So we have to push it up into orbit all the time. So it's going around the world every 90 minutes. As you know, we see like 16 sunset sunrises on ISS. So yeah, that's my answer.
Chidambaram from YouTube asks, launch pads undergo a lot of thermal and acoustic fatigue, so it would have a limited lifetime. Could you please tell us the exact lifetime of a launch pad or its components?
A very good question, because that's very near and dear to me. I spent all my life there, I guess, looks like. Yeah, Launchpad goes, they get extreme high acoustic loads of 190 decibels plus. I can tell you many stories about big camera covers flying off at Mach 1, Mach 2, Coke cans flying and structures flying, alligators and turtles flying, But yeah, it's 100 Gs, 3000 degrees temperature. So we are very particular about making sure that, especially when we transition from Apollo to shuttle, as you know, Apollo didn't have the solid rocket boosters. Solid rocket boosters provide, a very high intensity of thrust. It's called the ignition overpressure peak, which is very critical, and that creates a lot of damage on the launch pad. So the original plan was just to design the launch pad for the Apollo days, but then Apollo ended up. So we had to modify the pad to suit the shuttle. And luckily, we could use both two launch pads, 39A and B. 39A is the pad where man went to moon, actually. And 39B is where, now is being used for Artemis. So these are the two pads we have. And they could be used for more than 100 launches, but there is a lot of repair work. And now, because we don't own pad A, we don't worry about it. But pad B, we took out a lot of structures and systems so that it's designed for Artemis as a clean pad. But what is important, I think he wanted to allude, is we put about 300,000 gallons of water on the pad, so it mitigates the sound in the thermal pressures. So at liftoff. So when we had the movie Swadesh, luckily Ashutosh Kawarikar and all his team, they could see we didn't have a rocket on the pad, but we put 300,000 gallons of water per minute on the launch pad, and it was tremendous water flow, during liftoff. So that cools down the launch pad.
Also, just following up on the launch pad question, different engines must produce different kinds of temperature corridors and different thrusts, right? Like the space shuttle main engines would be very different from the F1s or say the Merlins that SpaceX uses now. So when you're designing a launch pad, do you think about the scalability, or do you think about the immediate missions that you're going to be using the launch pad for?
Well, very good question, because see, when you start scalability, in the old days, people thought that they could make things bigger and better, and by making the rocket bigger, but it doesn't work that way. And that's where the many earlier vibroacoustic failures came about, because the structure you cannot just scale it linearly. There's a very good book by Henry Petrosky. I want all your students to read. It's about failures, but it's called Success Through Failure, a Paradox of Design. And really, it talks about scalability there. But really, we designed the launch pad 39A and B for Apollo. And the thrust for the Apollo was almost 7.5 million pounds, which is almost 4 million kilos. But whereas the shuttle was about 3.5 million kilos. So we lucked out there. But what was the problem was that the Apollo F1 engines were liquid oxygen kerosene, whereas this one had a solid rocket booster, and that created some problems for us. And that's where we started putting a lot of water, because we had a big thermal cracking on the mobile launcher where the rocket sits, the space shuttle sits. We had a 20-foot crack after liftoff on the first launch, STS-1, in April 12, 1981. So very good question. So we designed now all the thrusts we required for the future rockets will be in the same range of Apollo and Saturn V. So we are lucky, unless we start taking more and more bigger payloads.
So we also wanted to know if, I'm modifying the question slightly, has there been any particular book that you personally found very inspiring and something that kind of changed your mindset? And secondly, is there any book more closely related with aerospace engineering that you would really recommend to, an aspiring aerospace engineer?
I think more than aerospace engineering, I would say read all the papers, all the information done by Henry Petrosky. I think he's one of my heroes, basically. He thinks like Leonardo, and I think like both Henry and Leonardo. He's a Duke professor of engineering and a brilliant mind. And I think you need to understand the philosophy of success and failure. And once you know that, then obviously systems engineering, and we talked a little bit about multidisciplinary knowledge. All these things are not written anywhere, but I think success and failure and root cause analysis are very important. And how you innovate yourself, that's the fundamental thing. Because if you don't innovate yourself, you're not going to innovate anything in this world. So.
Also, since you worked on the glider and the space shuttle, do you think we're going to see a return of the glider sort of re-entry corridors in the near future? Do you think that we'll be doing single stage to orbits anytime soon? Or is the conventional headlight shaped capsule the way to go for the near future?
Yeah, my gut feel says that I don't believe that we'll ever go back to the shuttle design. Don't forget, shuttle design came way back in 1980s. Werner von Braun was sending rockets to space on the Apollo program. He already was thinking about building the space station. And if you look at current designs of rockets, the other day my daughter was here and we had a launch, and she said, "Dad, 1969, we are doing the same thing. We are taking this module and landing on the ocean. We haven't progressed. That's not innovation. We are regressing or what? So basically, shuttle was a unique design. It will nothing. I call the Indian Pushpak Viman. And when I was a kid, my mom would say, there's a Pushpak Viman, and the god will sit and come back to the earth. And that was a beautiful Pushpak Viman. So really, I don't think that anything close remotely will be possible. Imagine 500,000 kilos of material sending to space. It would have been impossible with the volumes we're talking about without the payload compartment in the space shuttle. No rocket can take it now. So shuttle capacity was almost 12,000, 13,000 kilos. A lot of rockets can take bigger amounts. Maybe SpaceX is working on it. But the problem is the volume is a problem. We wanted volume also along with the weight.
Okay, so what exactly protects the spacecraft from micrometeorites?
Good question. So basically, we have we have a place in Colorado called the NORAD, North American Air Defense Command. Okay, so basically, North American Air Defense Command is a secret organization. It is under the Cheyenne Mountains, almost like 3 miles down or whatever, and everything is secret. And people there are tasked working with NASA. They're part of the U.S. Air Force, or now it's called the Space Force. So they're tasked to put an imaginary rectangle over the space shuttle. So as the space shuttle goes to space and goes around the Earth and around the world in 90 minutes, we have this imaginary rectangle, and we are following that rectangle very closely. So even a tiny 1 centimeter object or even lesser diameter object comes very close to it. We have a third type of fuel. We not only have liquid oxygen, liquid hydrogen, but we also have solids to lift off. But in space, we use what they call as hypergoals, called the monomethyl hydrazine nitrogen tetroxide. So we move the orbit. So we have 70 nozzles. We thrust the nozzles, use the thrusters to move the rocket out of place. So because space is three-dimensional, we can move it in any way depending upon where the object is coming. And we are monitoring it 24/7. Even for the space station, we are doing the same thing. Now, space shuttle is monitored very carefully. Well, space station also, but space station has many layers of protection. It has metal components which cover some critical areas depending upon where the hit is going to be. So we made a computational fluid dynamics model, and this model tells us exactly where the meteorite can come from, which direction, and those directions are covered by special materials, which are heat shields, we call them. They're not heat shields, they're shields to protect from micrometeorite. MMOD, which is called micrometeorite damage, is one of the very critical damage. And we had a small hole in the shuttle one time, and we had to plug it, because a leak in the crew compartment will be a very bad day for us.
Also, we had one question about, can you just like briefly tell our viewers what is up with the James Webb Space Telescope?
Well, I think they had some issues. It's going to go at Lagrange point. So basically, what happened was, I think there's a systems engineering problem. I don't know exact nature of the problem, but when you have a systems engineering problem, with the mirrors changing dimensions and all that, just like, we had some minor problems on the Hubble, which is, man-made again, root cause was man-made. Here also is systems engineering. Somebody messed up the mirrors, and so they're going to be having some aberrations and some deflections in space. So because of that, they shut the project down. Well, not shut the project down, but delayed the project, so that I think it will go in 2026 or 28 maybe.
That's about a decade late.
Well, it's better a decade late, because don't forget, Hubble, we could go and repair it because it was in low Earth orbit. So although we look like real fools, I guess, when we launched Hubble, but look at what Hubble has done for us. We went back and repaired it 5 times actually. So that tells you the tenacity and the ingenuity of engineers. So,
in fact, like everyone,
but we cannot go and repair something like this telescope in Lagrange point. It's very far away, 1 million miles away. So we cannot go there to repair, unlike Hubble.
Utkarsh asks, if you're familiar with the Dream Chaser, can you tell us your views on it?
It's a secret project. All I know is it goes up and lands, and then if you go near the building, I used to go to that building all the time because it was called OPF. OPF stands for Orbiter Processing Facility, and that's where we used to bring orbiter after landing on the SLF, our landing pad in NASA, not landing pad, but the landing runway. And now it's all completely locked up. And I think it takes a lot of pictures, secret pictures, and it stays there for a long, long time. And I'm not supposed to know anything about it.
Okay.
If I go near the building, they'll shoot me. So.
I think this is a slightly different question, but this is about how people who come from a certain background, their parents, the people whose parents can afford like private flying lessons or international internships. Do you think there's some sort of role of privilege that plays out if you training to be an astronaut?
I would say yes and no. I don't think Kalpana Chawla was in any privilege than me. I guess I didn't have money either when I came. I mean, I couldn't afford to fly. Maybe now, but not then. So yes, there could be some privilege, but I think astronaut office, which I supported quite a bit with astronauts, they always look for people coming through hardships. They want to know how courageous you are. What is your attitude towards all these things, setbacks and deviations, and things like that. So they give you high marks when you come on your own, basically. Only thing I think Casey had was that she married this guy, who happened to be her neighbor or whatever in the school, and he happened to be a pilot. So I think sometimes they say that you have to be at the right place at the right time, but I think you have to take opportunities, and she did take opportunities.
Yeah, and right, we've got quite a few questions about, as aerospace engineers, in your very long career, can you point out certain skills that you have found which determines the success of engineers, especially in the aerospace field? And what skills should students therefore work on from a young age itself?
I think if again, it's a question of passion, what they're interested in. I'm a mechanical engineer because RV College didn't have aerospace engineering, and I didn't even qualify for that. So we only had mechanical, electrical, and civil, and maybe there are a few people in electronics, and only the good people went to electronics, and everybody else went to other places. So anyway. When I came to Chicago, our department was called Mechanical Aerospace Engineering. So by default, I was part of aerospace engineering, but I did railroad research. There was no money for aerospace research those days. So General Motors paid for my research in railroads called tribology. Tribology is friction, wear, and lubrication. So I think that, I don't see that as a problem. You study whatever you want, but I think what aerospace engineers have to have is these four things I talked about. Which comes from not from going to school or getting experience. Well, maybe experience, but shuttle and Columbia and maybe Apollo 1 fire, Apollo 13 disaster, all point out to one thing for me. That you have to be the best in understanding failure analysis, root cause analysis, systems engineering of systems, multidisciplinary knowledge on many different areas, and documenting the fact and storytelling. Basically, I think these are the skills you need. Some are like systems engineering. You're seeing the picture from you're seeing the forest, not just a couple of components on the ground. So I think that is more value. If I want to hire one of your students, that's what I would look at. Does he have this big picture approach? Does he have understanding of many fields like metallurgy? But luckily for me, I worked in mechanical engineering, but I did metallurgy and a little bit understanding of tribology, and then I did instrumentation. I think I told you in mining testing, and basically for helicopters we did vibration and finite element structure analysis. So some comes from engineering school, school education, but some comes from hands-on experience. But nothing prepares you to we have like almost 1 million acronyms in NASA. How do you, or even 100,000 acronyms at Kennedy Space Center, how do you know all that? You have to go physically and touch it and feel it, and that's when you know it.
Right, and a couple of final questions. One is, what were some of your maybe one or two really profound, happy moments of your career in NASA, and that vividly that you can remember even today?
Oh God, I think that's a tall order. I think maybe as I started traveling around the world and giving lectures and meeting many people, I was in Dubai one time, and I opened the movie called The Hidden Figures premiere in Abu Dhabi. And as a kid, I used to grow up there in 1967. My dad worked in oil companies, and we lived in Abu Dhabi, Dubai, and Muscat. And so when I opened the movie, the Crown Prince of Abu Dhabi was supposed to come, but he didn't come. So he sent his grandson. So grandson was very interested in the movie. As you know, Hidden Figures was one of the very finest movies NASA had about NASA. And so after the movie, I gave him some gifts, like my book, Infinite Worlds, and some shuttle models and all that. And he was asking me about my things. And I said, look, I used to live here in Abu Dhabi, and my building was taller than your dad's building, the Sheikh of Abu Dhabi's building. And he was laughing, you should be a citizen of Abu Dhabi. And then this small girl in the audience, she's a British kid, because a lot of ambassadors and, American British ambassadors came. She came running to me, and we were with the Crown Prince's grandson. She held my leg and she pulled my hand down, and she says, Dr. Ravi, I want to go to moon, but only with you, I think that made my day, basically. One other time, I think, would be, obviously meeting Kalam was great, but I think I was in Australia one time and I was giving a lecture, and I saw the dichotomy. You were bringing up stories about rich and poor. I went to a rich school. My best friend's daughter, she went to school there, all girls school, and they had beautiful auditorium and ultra modern. And none of the girls except my friend's daughter came to talk to me, and they were all aloof and very uppity, I would say. And I had a lot of things to eat and drink and everything. They took care of me like royalty. But then I go to this Aborigine school, Aborigines of Australia, they're like outcasts sort of. And this Aborigine school, they welcomed me just like the other school. And they had 400, 500 kids. They all sat in the stadium on the floor. They didn't even have chairs and tables and no air conditioning there. And a group of 10 people came and did a spirit dance for me, an Aborigine dance. And then the small girl came and gave me a picture of a alligator sleeping, or doing something, dreaming. Alligator dreaming. And dreaming is a word for they use in the bushes there. They talk about how alligators move, or how the kangaroos move around and stuff like that. It's a behavior of animal. I think that was amazing for me. That here I saw the dichotomy of two different places, one rich and one poor. But it put me in a different world altogether. And then last but not least, I think I will take a chance that the day we launched Kalpana Chawla, and in a million years, I would have not thought that I would ever work for NASA, but also ever launch her. And we were like, I was doing not only vibroacoustics, but also doing systems engineering. Then I was doing VIP tours for the Indian ambassador and ISRO people. And we were like in a cordoned off area where nobody is allowed. One day before launch, we got to talk to her. Everyone, 16 people in the group. Then the second day, the day of the launch, we met her like 2 feet away when she went to the Astrovan. 3 hours later, she got launched. And 8 minutes later, she was in space. And then we got her back safely on STS-87, which was again Columbia. And then Inder Kumar Gujral talked to her in space almost an hour. He called her a beautiful swan swimming in the heavens. And I felt good that, I had done that, something contributing to more than my picture on the wall in the $100 million museum or whatever. I think these are some of the stories, and every country I went, I had some stories like that, which I would want to, share that in my book when I finish it. So.
Yeah, and coming to that, can you also tell us about the book and what you're planning to put into it, and when we can expect to read it?
Well, I think it was in the planning about 15 years or so. Whenever I used to take my daughter to school, she would say, Dad, what are you doing today in NASA? And I would tell her what to do and what we are doing and launching a rocket. And she would always, then as she grew older, she got to liking to reading, and she was reading quite a bit. Pamela Melroy, one of our astronaut friends, which I'll also talk a little bit, she gave her a lot of books. And so this book was for Nina. So I was planning to write my memoir about my NASA work and, how I came to America and my journey to America and all the ups and downs from India to America and how I ended up in NASA. But more importantly, when you start a journey, you have to end it. Her journey didn't finish. She died in Colombia. And so, I thought maybe it's a good time to talk about her also in the journey, because I got to launch her both times. Um, I came last year to Mumbai, and we opened up a chapter. Sort of, had a closure on that journey. But I think more importantly, I wanted to shape today's youth into tomorrow's leaders. I started mentoring some people. I have few students now I mentor. Uh, and I want to create masters, shaping today's youth into tomorrow's masters. Like master is one who is not measured by the number of students he has, but by the number of masters he creates. So we want to go beyond what Swadesh did. I think each one of the students is a rocket. The only problem is they're sitting on the pad with no ignition and no fuel. So that's what I want to do. Put passion in their heart and ignite their minds. That's the rocket needs fuel and ignition. So there are 100 million rockets like that ready to take off in India, and I hope that my journey and my story will inspire them. That say, hey, if this guy, who was an ordinary guy who failed in exams and other things, can do these many things, I can do better, and I can do it too. So I think luck favors the prepared mind, but more importantly, you have to seize the opportunities and not worry about the detours and mishaps and near misses, close calls and accidents and other things. And that's where plan A comes and plan B. So, plan A was just flying 5 miles like the movie, but plan B gave me much go beyond the solar system, which I didn't even know that it existed. Launching something to Venus or Hubble or Galileo or to Jupiter and Cassini to some of the planets like Saturn. It's amazing, or looking at even what Voyager 1 did, and now looking at Curiosity rover and launching a helicopter on Mars. That will be the ultimate. So we are sort of I always felt that I was an ordinary person in an extraordinary space. We are sort of hidden figures of NASA, like the launch team. But for every right stuff to be reaching in space, the astronauts, we need the right stuff on the ground. Without that, nobody can go. And Dr. Kalam was right, always, that the ground staff is very important. So basically, the credit goes to the rocket. Cannot go to space without us. So you can build the best rocket in the world, put the best astronauts in the rocket, but it cannot go to space without us. So I think I felt good that I was part of that team. And why it happened, I have no idea, but that's my legacy. And so when I talked to to Pamela Melroy this morning, she sent me a note from on one of her LinkedIn messages and messages today on email. So she said, I want to tell you a small story about Kalpana Chawla. So one day they went to Montana, and this was an anecdote. And she and Kalpana Chawla were very close friends. They always flew in T-38, which is the aircraft. They come from Houston to Florida. And so when we had Columbia accident, Pamela Melroy was the one who did the accident investigation, root cause analysis. So she says they went to Montana together. This was before the first flight, and they were happily enjoying hiking and biking and enjoying staying in a small bed and breakfast. And she got to know Kalpana more, and basically they stayed in a place where this family were very old people, 2 old people, husband and wife, and a bread and breakfast. And they thought that these two were their own girls, and they treated them like girls. So when Casey died on Columbia, they called Pamela Melroy and talked about her. So I think everybody has a journey. I think one has to start the journey. Without that, nothing happens, basically. So I think my recommendation would be is to just embark on it and let it take you wherever it wants to. And in the end, it may be a serendipitous journey. like many people,
Thank you. And is there any other last closing remarks or advice you would give if you had the chance to speak to your younger self? Someone who's 20, 22, starting off on this exciting journey, not sure about everything, and dealing with a lot of uncertainty, especially right now with the pandemic and so on. So, is there any advice you would give us?
Well, I think I use this in my innovation lecture. So basically, this is what it is. Nobody knows who they are, and they're venturing in the unknown, so they're always afraid. So, like, innovation is like seeing the unseen, hearing the unheard, and knowing the unknown, basically. So, seeing the unseen means, like, when Michelangelo was given a block of marble, I went to Rome to see that beautiful statue of David. Most of the artisans, they didn't want the marble because it had cracks and other things. But Michelangelo saw a beautiful statue of David in there, and he took the challenge to use that marble. So that's seeing the unseen. Hearing the unheard, two examples I want to give. One is, when you play the piano, I never knew this, that, you just don't keep on banging the keys. You just give a gap in between. So that gap is also music, And so basically, those gaps are really the silence in between the two strokes are what I call it, the hearing the unheard. So in the context of the space shuttle, everybody, we have millions of people around the world, including hundreds of millions of people in NASA and outside NASA. Once the shuttle takes off, they would clap like crazy, And I'm like waiting for the rocket to take off. And as it takes off, there are low frequency sounds below 20 cycles or 20 hertz, 0 to 20 hertz, human ear cannot hear. Only 20 to 20,000 hertz human ear can hear. So those sounds come to a distance at the speed of sound at 1100 feet per second or 343 meters per second. It takes about 15 seconds where I'm standing right next to the VAB, which is one of the tallest buildings in NASA. And when it starts vibrating your shirt, then you feel part of that rocket. You feel that you have done something important, and you are going above this particular zone called max Q. And max Q is the maximum aerodynamic pressure. So then I feel that the rocket is safe. Last but not least, knowing the unknown is basically, you're going all on an unknown journey, like many of us, So when I left India, I should have been back in 6 weeks. But I think you should go after your journey and try to embark on it and, take the risks, And yeah, sometimes you fail, and sometimes fear affects you and stuff like that. But I think one thing I would say is there may be a secret destination for all the travelers, and I think you may find something. There's a very good book called The Alchemist from Paulo Coelho. I think if you guys want to read it, that's a nice book about how the small boy takes a journey and comes back. And so I don't want to tell the story, but the name of the book is called The Alchemist. So I want you to read that in addition to the book I told you by Henry Petrosky, The Success Through Failure, is a paradox of design. So success through failure is, success and failure are two failure is stepping stone for success, but success and failure are same side of the coin. Basically, they go along with it. You learn more from failures. Like we learn more from Colombian Challenger than successes. So, and like, if you don't believe me, believe Kalam. Dr. Kalam. He said in his book, Wings of Fire, he said, you have to have failures. And he had first failure on his SLV3 or whatever. And he said, look, I failed, no problem, because this failure helped me to reroute and change the direction, change the path, and take me to my destined goal or objective in the end. So, or my destiny.
Okay, that's been an amazing conversation.
Yes. Thank you so much.
Well,
So
thanks for everything, and appreciate and hope your audience, had some knowledgeable discussion here. Learned something from what my mistakes are. So it's all about them doing better. So not only learn from your own failures, but learn from others' failures, right? So
I think the audience will definitely walk away with a lot more insight and clarity to some questions that we find pretty hard to answer. So thank you so much for that. I also want to thank you for your time, because I know it's not easy right now. I guess you would rather prefer to be physically present in such conferences that you've done in the past as well. But I'm so thankful that you kind of adapted to the change and accepted our invite to be virtually present here. So once again, thanks for your time. It's such a privilege to be able to connect with people like you. And once again, with Nakshatra Sciences, we really stand for making such quality information and knowledge available to everyone. And if not for free, at affordable costs, but either way, our objective is to break down boundaries and walls and just make it much more inclusive for the entire scientific and technical community of India, and also a global platform. So with that, I would also like to thank all the participants. It's been so nice over the last 2 days. We've got some amazing applications, some amazing questions. And it's intriguing to know that there are so many people out there with that kind of passion, people with the same level of work ethic and drive, who are really working on their goals. And it's very inspiring to connect with such students from across the country. So thanks a lot for showing interest, and as well as being a part of today's event particularly. And of course, last but not the least, everyone in Nakshatra's core group who have been vital to this entire process of bringing the event together, putting the technical aspects of it, and as well as reaching it to the people so that they can all get an opportunity to hear us today. So thank you so much. Thank you, Karthik, Jeevan, whoever has been really, really helpful over the last 1 week. Thanks a lot. And with that, we will end here. If any of you have more questions for us, if you have some question that was not answered today, that's all right. Please write to us. We are open to questions. Or if you've already joined our discussion forum, you might want to just leave the questions over there. I think there are some questions coming in about Project Possum, but I think we will be having a separate talk with Akshat, who is here today as well. So don't worry about that. We'll have a talk, I guess, just in the coming week, specifically for this. And those of you who have those questions can log in, tune in again, maybe in the next Saturday or Sunday. So for today, this is it. Once again, thank you. And we will see you, I guess, every other weekend over here for the next 2 months. And we also hope to see you on our discussion forum. And Dr. Ravi, thank you so much. We hope you can remain as a mentor and someone who gives us the advice when we need it. So thanks a lot for being here.
Yeah, we need to launch a lot of rockets from India. Okay.